In the early days of containers, we started with namespaces and control groups, which weren't perfect by themselves when we wanted to run groups of applications, so we moved to a higher abstraction layer, which is the container image. So groups of containers also share the host kernel on the host they run. So by themselves, containers are very lightweight and bring a lot of benefits, but due to the kernel sharing, it's not a true sandbox. You need to make sure you consider the traditional security principles of least privilege, defense in depth, and reducing the blast radius still apply to a containerized environment, except they need to be applied in a different manner. Containerized applications may run differently to that of a monolith, but the bad actor's intent stays the same. So think of an image as a bunch of layers stacked on one another, but it looks and feels like a unified file system. So there's some magic in the background, but all of this looks like a single flat image. So we have a number of layers that make up a container image. The container image encapsulates your application code and any dependencies, third-party packages and any libraries. So now you have everything you need to run your application in a single image. So you should consider images as the build time construct, and then on the other hand we have the containers that are the runtime constructs. For a large containerized environment, you will need an orchestrator, and Kubernetes is the orchestrator of choice. You may have a platform that's running above Kubernetes, such as OpenShift, that will give Kubernetes better functionality and ease of use. So in a Kubernetes cluster, we have nodes that are known as worker nodes that run the actual workloads, which are our application containers. A node can have multiple pods, and the Kubernetes control plane automatically handles scheduling the pods across all of the nodes in the Kubernetes cluster. So just before we finish up, let's have a quick recap. So in a Kubernetes cluster, we have nodes. A node holds a number of pods, and each pod has a container inside of it that runs the application. So pods will have an IP address, but we don't access the applications that are inside of the pod by the pod's IP address. We access the applications that are running inside of the pod with what's known as a service. When you think of a service, think of it like a VIP that sits in front of a pod or a group of pods. To communicate to the external world, we need NAT, and to communicate between pods on different nodes which are internal, and in the case of OpenShift, we would use VXLAN. VXLAN is used to efficiently tunnel traffic from one pod to another.